So how to find out solution of recurrence relation using generating function. So suppose we have the recurrence relation. So an is equal to 3 times an minus 1, 3 times an minus 1. Yeah, that's it. And suppose I give initial condition a naught as 2. A naught as 2. So it's clear that this is valid for n equal to 1 onwards. Okay. So a1 ka value you can get with the help of this formula a2, a3 and so on. Okay. And you have the initial condition a naught as 2. So let's see what happens. Okay. How we are going to use generating function. Let's call it as 1. So how we are going to introduce. Right now I have just the relation which represents nth term of some sequence to n minus 1th term of the same sequence. Okay. So what we do? Let an be the sequence that satisfies above the recurrence relation given by 1. So this is the sequence an which is unknown right now and that satisfies this recurrence relation. So how this method is different from the previous methods? In previous method we used the characteristic equation and very easily we got the answer. And what we are going to do here, this is the relation which is available with us. We are trying to sum up all the terms of this sequence after multiplying by suitable powers of it. जैसे कि if I multiply both sides of 1 by x raised to n. So what I am going to get an x to the power n 3 times n minus 1 x to the power n. Okay. So as if n 0 हो सकता है, n is equal to 1 हो सकता है, and so on. Okay. So if I take n x to the power n is equal to 3 times n minus 1 x to the power n. So now take sum of all the terms of this expression, sum of all the terms for suppose n is equal to 1, 2, 3 and so on. Purposely I am not writing right now a naught or a 0 or n equal to 0. I am saying now take sum of all the terms for n equal to 1, 2, 3 and so on. Because यहाँ पे हमें दिया है ये जो relation है this is valid for n greater equal 1. तो क्या होगा? So for example a1x एक term आएगा a1x, दूसरा आएगा a 3 times a naught x. फिर नेक्स्ट इसका नेक्स्ट इक्वेशन बनेगा a2 x square equal to 3 times a1 x square. Then a3 I'm putting n equal to 3, a3 x cube 3 times a2 n is equal to 3 x cube. ऐसे सभी equations if I add take sum of all the terms for various values of n. So what I am going to get sigma of this term sigma an x to the power n यहाँ पे sigma 3 times an minus 1 x to the power n. And as I said, n is varying from 1 to onwards. N is varying from 1 to onwards. Okay. So here After comes the actual arrangement part. So this can be written as A naught plus sigma n varies from 1 to infinity, or just a minute. Okay. Let gx be the, so let's call it as some equation. Let's call it as 2. Let gx be the generating function of an. Let g of x be the generating function of the sequence an. So with this assumption or with this definition, what I get, we have sigma n varies from 0 to infinity, an x to the power n is equal to g of x, is equal to g of x. But here this n is varying from 0 to infinity, and you can observe here this n is varying from 1 to infinity. So it's just a matter of difference of one term. यहाँ पे 1 to infinity जा रहा है, यहाँ पे 0 to infinity जा रहा है. So what I can do is, with the help of this setting of gx equal to this, what I can write, sigma, can anyone tell me the answer? क्या होगा? n varying from 1 to infinity, an x to the power n का वैल्यू क्या होगा? इसका वैल्यू can I say this is gx minus a naught?
Yes.
So that will be gx minus a naught, because this summation is varying from 1. तो यहाँ का फर्स्ट टर्म होगा a1x, whereas यहाँ का फर्स्ट टर्म होगा a naught plus ये सभी टर्म्स. So with that I can write this summation as gx minus a naught. But I know the value of a naught. A naught का वैल्यू हमारे पास दिया है, a naught is 2. A naught is 2. And so if I substitute in 2, okay, so let's keep this as it is. One more we have. What about 3 times sigma n varying from 1 to infinity? This 3 times an minus 1 3 times an minus 1 x to the power n. This can be rewritten as 3 times sigma n varying from 1 to infinity n minus 1 x raised to n. This can be written as 3 तो I took common. I'll also take x common. एक x हम common लेंगे. Sigma n varying from 1 to infinity n minus 1. Now this power will reduce by 1, that is n minus 1. So what happens? This is 3x. इसको rearrange करेंगे. Sigma. This is 1 to infinity. So I'll make it 0 to infinity. A. What I supposed to write? Someone tell me what I supposed to write here.
N.
An x to the power n. But what is this sigma an x to the power n? That is 3x as it is, and this is the value of g of x. So I got the simplified term for this, as well as I got simplified term for this. तो ये दोनों वैल्यू हम कहाँ पे पुट करेंगे? We'll substitute in the equation 2. So इसको you give some, say this is equation star and this is equation double star. So using star and double star, equation 2 becomes क्या बनेगा इक्वेशन 2 gx minus 2 equal to that becomes gx minus 2 equal to 3 times x g of x 3 times x g of x which can be written as gx into इसको शिफ्ट करेंगे 1 minus 3x इसको शिफ्ट करेंगे equal to 2 which implies g of x is 2 upon 1 minus 3x. तो मैंने एक जनरेटिंग फंक्शन फाइंड आउट किया है g of x, बट अवर अजम्पशन क्या था? दिस इज द जनरेटिंग फंक्शन, दिस इज द generating this is the generating function of an, this is the generating function of an. तो इससे आपको an के बारे में पता चलेगा. तो 2 upon 1 minus 3x is equal to sigma an x raised to n. तो हमें सिर्फ ये देखना है कि what will be the value of, इसको कंपेयर करके हमें an की वैल्यू फाइंड आउट करनी है. So what can be done? Just before some time we have seen this 2 upon 1 minus 3x is actually equal to, can anyone tell me ये किसको equal करेगा? This is 2 times, isn't it sigma n is varying from 0 to infinity 3 raised to 3 raised to or 3x raised to n. I'll say sigma n is varying from 0 to infinity 3x raised to n. I'm using the above equation. देखो ax plus a raised to 0 x raised to 0 which is 1 plus ax square and so on, that is nothing but 1 upon 2 minus, sorry, 1 upon 1 minus 3x and the whole thing is multiplied by 2. So I'm just comparing that a. यहाँ पे मुझे a 3 दिख रहा है, so a raised to n x raised to n. So it's clear that which implies that an is equal to, ये 2 तो है यहाँ पे, and this is 3 raised to n. ज़्यादा से ज़्यादा what you can do is sigma 2 times n from 0 to infinity 3 raised to n x raised to n. So I can see 2 times 3 raised to n is the an का value. If I compare with the standard format, is the required solution.